This is IEQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IEQ Radio Plus. This week is episode 660, and we welcome back after a 12-year hiatus from the show, Dr. Andy Persily from the National Institute of Standards and Technology. We're going to talk today about CO2 and ventilation, indoor air quality, maybe a little on infectious airborne transmission. So looking forward to a great show. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget after the show to continue the discussion at afterthoughts.ieqradio.com, sponsored by First On Site. Our marquee sponsor is First On Site at firstonsite.com. Our association sponsors are the American Industrial Hygiene Association, AIHA.org, the American Conference of Governmental Industrial Hygienists, ACGIH.org, the Cleaning Industry Research Institute, CIRI Science.org, the Indoor Air Quality Association, IAQA.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org. Industry sponsors are AEML Laboratories, AEMLINC.com, Particles Plus, ParticlesPlus.com, TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, April Air, April, AIRE.com. Healthy Indoors Magazine, healthyindoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. I'm glad to report that Dawn Weeks from Ottawa, Ontario, Canada, was first to identify Wallace H. Coulter as the American who patented a method for counting and sizing microscopic particles suspended in a fluid. The IEQ Radio Trivia question for today, April 8th, 2022, has been sponsored by TSI Inc., an industry leader in precision instrumentation for the monitoring of indoor air. Learn how to expand your IEQ investigations at tsi.com. Here's IEQ Radio's trivia question. At what time does counting solar mean time begin? Back to you, Joe.
All right, thank you, Cliff. Today we welcome back Dr. Andrew Persily. He's a fellow at the U.S. National Institute of Standards and Technology, where he's worked for 4 decades. His research has focused on indoor air quality and ventilation in commercial and residential buildings, including the development and application of measurement techniques and predictive models. He's published more than 300 journal articles, conference papers, and NIST reports. Dr. Persily was a vice president of ASHRAE back in 2007 to 2009. He's a past chair of ASHRAE Standard 62.1, the Ventilation for Acceptable Indoor Air Quality Standard, and he's a fellow of ASHRAE, ASTM, ISIAQ, and a recipient of the NIST Bronze, Silver, and Gold medals. Welcome back, Dr. Persily.
Thanks very much. It's great to be here and good to see everybody.
Always good to have you. It's been too long, 12 years, unfortunately. I was kind of shocked when I saw that.
Yeah, I wouldn't have remembered if you didn't tell me. I was going to go back and listen to the tape broadcast yesterday, but I had just eaten lunch and I didn't want to, upset my stomach. So yeah, I wasn't able to find the time, but I'll have to do that sometime. I'm glad you did, though.
Well, I did. I went back and I listened. Also, we're going to, next week is Good Friday and the start of Passover, I believe, and Easter's coming up. So we usually do like a flashback show. I think we're going to do that one next week for those that didn't get a chance to hear us 12 years ago. It holds up really, really well. But since then, your position at NIST has changed. Can you tell people what you do now?
Sure. So 12 years ago, I was the leader of the Indoor Air Quality and Ventilation Group, and I had probably been doing it for about 12 years, maybe for 20 years at that point. And kind of halfway between this 12-year hiatus, I became chief of the Building Energy and Environment Division. So here you're showing the page for the group that I led for a total of 25 years. But then about 7 years ago, I became division chief of the overall Building Energy and Environment Division, which included the indoor air quality work and some, HVAC and our hardware, work and so on. And then about a year ago, I was named a NIST Fellow, which was a tremendous honor. It's like, I think there's 40 fellows at NIST, and when, and they're sitting there, and when one of them dies or retires, they open up the chair for another fellow, and I was, awarded the great honor of becoming a NIST Fellow, and which means no supervisory responsibilities, less email, fewer meetings, and I'm supposed to do some research, and they even give me a little money for a postdoc. So it's really great. My outlook on life is much improved. For people who know me, you'll notice today that I'm much less crotchety than usual.
Yeah, you're also, now NIST is part of Department of Commerce, is that? And it's a huge organization. I mean, you cover a lot of things. Well, maybe it's not as big as, when you look at the perspective of government organizations, maybe NIST isn't as big as huge, but a big organization does a lot of things. I don't think people realize how much work is done through NIST.
Yeah, I mean, as you say, it's part of the Department of Commerce, and there's all sorts of cool stuff. I think there's about 2,500 or so people in Gaithersburg, Maryland, and then another 500 in Boulder. It's been around for more than 100 years. And it's one of two national labs created by an act of Congress. I can't remember what the other one is, but it's a good trivia question. And actually, the new NIST director was just confirmed by the Senate yesterday, Lori Locascio, and so we're all excited to see how she, await her fingerprint on the organization.
When I listened back to the old show, we were talking about what's called the EPA Base Study, and how you were a part of that and how important that was. And I just thought I'd really like to bring it up again, because I don't think enough people realize what that was. And when we talked the other day, you told me how it got started. Can you tell listeners a little bit about that?
Yeah, hopefully you won't compare what I said 12 years ago. My recollection is that, so this is kind of the mid 80s or something, and there's always indoor air quality studies, and people are, they tend to focus on problem buildings, where there's a lot of complaints. And so they go in and they learn that, 40% of the occupants had a headache last week. Oh my God, or they learn that they measure this contaminant and it's this high. And the idea of the base study was to measure buildings that weren't on the front page of the paper, buildings that weren't notorious problem buildings, and see how many headaches they had last week and how high the VOC levels were and what were the ventilation rates. So it was to establish a baseline so we could compare all these other, supposedly more problematic situations. And there was 100 randomly selected office buildings in the US. And, but one thing I'll note, maybe I said it 12 years ago, if you go to any building and look around, you will find problems, you might not have to look that hard. There may not be problems, that are causing, death and severe disease, but superior operation and maintenance is rare. So that was kind of the base study. I think most of the measurements were made in the mid 90s, if I recall right.
It was kind of a foundation for people to look at. Okay, now here we have this, and who else would do that kind of, who could do that kind of research?
Yeah, I mean, it was run by EPA, but they brought together a big group of people to basically design a protocol, right? And there was a similar project done in Europe afterwards, the European Audit Project, but it's kind of, it's different. It's different buildings, different priorities, and nothing really has been done since. There was a study in California did, and I think small and commercial buildings, small and medium commercial buildings. I can't remember how many they did. And they kind of built off the base protocol to a degree, but you know, it still comes up occasionally. Somebody says, is there any data out there on, you know, thermal comfort in office buildings? Well, that's a bad example because there is some of that, but there's, you know, it does come up still, and nothing has been done since, and it's still quite relevant. You know, a lot of data was collected, and only I think a fraction of it has really been analyzed.
Interesting. Now, this was back in the 80s. And through the 90s, and I guess I've always wondered, like, how does the change in administrations, the change in topics, the change in times affect the type of research done through NIST?
Yeah, you know, I mean, NIST overall is, you know, that's a bigger question. You know, I mean, that's a lot of what NIST does is driven by industry needs, you know, and where innovation is happening. You know, I mean, a good example is as, you know, semiconductors and microelectronics and all that stuff have moved, gotten smaller and smaller. The measurement of length and small lengths has become really important to that industry. And so NIST has, you know, progressed in their, you know, measuring, you know, the accuracy of length measurements and small length measurements, and all the time stuff they measure, you know, links directly to GPS technology and all that. So, you know, if you went to that website again, I don't know what's on there, but it'd be cybersecurity and automated manufacturing and, you know, I don't know if forensics is still there, but, you know, and I mean, those are kind of the big issues. You know, there's information technology, nanotechnology, resilience, you know, so those are kind of driven by, you know, not just administration priorities and congressional priorities, but also, you know, industry. You know, a lot of what NIST does is driven by industry and technical needs to support, you know, support innovation, you know, to support U.S. industry in this crazy global marketplace. You know, then when you kind of get down to a topic like indoor air quality, you know, that's driven by similar motivation, but just, you know, building construction and design is not high tech industry. It evolves slowly, and you know, the IT people, you know, they're changing like this. You know, in the building industry, you know, someone does some research, someone writes a standard, someone writes a building code. It takes a long time for things to change, and cool new technologies developed all the time. But, you know, if I'm building, you know, if I need to replace my roof shingles, I don't want to use the shingles that just came out last week. I want someone else to use those for a couple of years. Oh, they're good. You know, now I'll put them on my roof, you know, down the road. You know, you don't want necessarily to go out on a limb on your building. And I'm kind of rambling, I'm sorry, but, you know, on the indoor air quality side, as I think we talked about the other day, you know, we've been doing work on airflow in buildings and how to measure it and how to predict it, and contaminant transport in buildings, you know. And when I first got involved in the late 70s, it was really motivated by, you know, kind of the first energy crisis. It was all about energy efficiency. And then, you know, the awareness of indoor air quality issues came up, you know, so a lot of what we were doing was motivated by indoor air quality. And then over time, the motivations evolved. You know, there was a lot of concern for a while there about chem bioterrorism, intentional or accidental releases, you know, and then we got, you know, more into green buildings and sustainability, and, you know, you know, and now, you know, we're kind of interested in airborne infectious disease transmission, and there's some other kind of big trends. You know, the good news is that the physics hasn't changed. You know, airflow is still driven by pressure. You know, there are holes in building walls. There are ventilation systems and fans and ducts moving things. So the physics hasn't changed. it's the motivation and some of the specifics have evolved over time due to, some of these external, pushes.
Well, the reason I got back in touch with you, and it was way too long, but I saw the paper that came out from ASHRAE. I guess it's a position document, they call them now. And this was on CO2. I want to make sure I have the indoor carbon dioxide. I don't have the title right in front of me at the moment here.
Yeah, that's basically what it's called.
Yeah, it's indoor carbon dioxide. And I saw you had worked on that paper. You were part of a group of people, and it's one of those topics we've talked a lot about. And sometimes it's confusing for you because it seems like things change a little bit. At one time we thought, well, indoor carbon dioxide is just a surrogate for maybe other indoor air quality issues. And then, you see some research that says, well, wait, maybe it's more than that. Maybe it is actually a pollutant. And I thought, let's get Andy back on here and let's talk a little bit about this document and see what we really know today about CO2. So maybe first you could tell us a little bit about the background, why the document was developed, and then we'll get into some specifics.
Sure. I mean, I will point out that an ASHRAE position document is really, it's approved by the ASHRAE Board of Directors. So it's a statement of what ASHRAE thinks about a topic. So it's pretty high level. There's position documents on climate change and energy efficiency and indoor air quality and filtration. So it's not a design guide. It's not a technical, report. Obviously, there's technical matters are discussed, but the feeling was that after decades of I'll call it confusion or mischaracterization of why indoor CO2 concentrations matter, there was a feeling on the part of some that ASHRAE should write a position document on indoor CO2. And this was before the pandemic that this happened. And, I won't mention any names unless you really push me, but, this individual who was pushing this, he wasn't going to write it. He said, Andy should write it. And I said, well, not this month, but I'll do it later on. And, so we started the process. The committee was fantastic. If you look at the roster, there's a lot of real sharp people who did a ton of work. And I, as chair, I was chair, but they, you can see lots of names of very capable people from around the world, who are involved in this. And so, we got together. And so if you read, there's a little history section in there. People have been talking about carbon dioxide in the context of building ventilation and indoor air quality for hundreds of years. It's not new. And it's a pretty interesting, as you get older, you like history more, right? Then when you're younger, it's like, who cares? But there's some interesting stuff there. That's the short section. There's a much longer one in the back. But it's been a topic of interest for a long time. And, within the last hundreds of years, as we, I guess the first ventilation standard in the US, I think it was 1946. And there was a ventilation standard for New York public schools, I think about 100 years ago. And so carbon dioxide started to get into that discussion, in part, because it's a good surrogate for the bioeffluents that people release. So when people do their metabolism, they release CO2 at a rate that's proportional to how active they are, doing metabolism, whether they're running or sitting or sleeping. And people also emit these bioeffluents, these products of metabolism that don't always smell real good, and so the first kind of ventilation studies were focused on the control of the perception of body odor. And so they measured, they asked people how bad they thought the odor was, and they also measured CO2. So that's kind of was the technical link. And then, what happened is the first version, not the first version, I think that the 1981 version of ASHRAE Standard 62 had a 2,500 ppm CO2 limit. And then they changed it to 1,000 in the 1989 standard. And then after that, it was eliminated. Well, I often like, people still say that, they measured CO2 and it was below the ASHRAE limit of 1,000. Well, ASHRAE has not had a limit of 1,000 for more than 30 years. And I often say, if I had a nickel for every time I read that, still, in new publications, in high-level academic journals, people are still saying that. And so that was, one motivation was to help people understand what CO2 means, this whole body odor perception connection, what the standards say, because why ASHRAE doesn't have a limit, other documents do. And the other thing about CO2 is it's a convenient tracer gas. And there's all these tracer gas methods for characterizing ventilation in buildings. And CO2 is a very convenient tracer gas because it's easy to measure and you have a built-in injection mechanism, which is the people. So it's been used as a tracer gas. Some people don't really understand that, and they don't appreciate that tracer gas methods are documented and standardized, and there's no mystery there. And so we talked about that as well in the document. There has been, you kind of alluded to this, in recent years, there has been some research showing that CO2 concentrations kind of in line with what you might, observe in a building, not in a building that's sealed up and has no ventilation, but it's kind of a normal level in the, 1,000 ppm range. There have been some studies showing some effects on human cognition or cognitive performance, but there have been other studies that didn't see those effects, and so we wanted to present, those inconsistent results, and inconsistent results is part of life, and it's part of science, and they need to be investigated, before we rewrite everything, rewrite all the standards. So there was that motivation, and then, with the pandemic, there's been a lot more interest in CO2 measurement and interpretation, and there's all these low-cost monitors coming on in the market, and people are, running around and measuring, and it's good to run around and measure, but it's kind of like you need to understand what it means. And while this is not a technical guide to the measurement and interpretation of indoor CO2 levels, I think hopefully it frames the bigger picture. And one of the recommendations in there is to develop, the more detailed technical guidance for practitioners.
Let's break it down. I have it broken down sort of like the paper did. The first in this segment is on CO2 as an IAQ metric. Interesting discussion. What are your maybe you can summarize for us what that means and what you came out with.
Well, again, if you read things out there, people will say, I measured CO2, it was below whatever it was, and therefore my indoor air quality is good. Well, there are lots of contaminants in buildings that are not going to be related to the CO2 level. Contaminants associated with emissions from furniture, for example, or contaminants that enter from outside, or all sorts of things. Contaminants that are proportional to the number of occupants in a space, maybe those will be linked to the CO2 concentration, but there's a lot of other important contaminants. So, while CO2 might be a useful tool, it's not, and the position document, clearly states that it's not a comprehensive metric of indoor air quality in general. Indoor air quality is too big to be captured by a single contaminant, and certainly a single contaminant that's only driven by the occupants.
Okay, and the next, the next segment is assessment of ventilation rates using CO2 as a tracer gas. By the way, I'll get to some of these text questions in a little bit here. I think this one is, at least the impression I got was that this is a really common use for CO2, and that it's for the most part being used appropriately. Is that Go ahead.
It's a mixed bag. I think some people, well, basically, tracer gas techniques, the idea there is you release something in the air and then you monitor it, do a little math, and you can back out an air change rate or some information about air distribution. People have been doing that for almost 100 years. Oldest paper I have is 1935, doing the tracer gas decay method, where they release a gas that wouldn't be there normally. They mix it up, and then they monitor the concentration decay over time, and they can get the air change rate. There's a few different tracer gas techniques. There's an ASTM standard, there's an ISO standard. It's well established, well documented. And as I said earlier, CO2 is easier to measure than some other tracer gases, and you have a built-in injection mechanism in terms of the occupants. Or you can just release CO2 from a fire extinguisher or something else in an unoccupied building. But not all people who do these tests realize that there's a well-documented methodology, and which has assumptions and limitations and so on. So they might do it and not really have educated themselves into what's behind the method and verified that they're doing it properly. Some people will run in, grab a concentration, and then back out a ventilation rate, which can be done, but to do that correctly, you have to assume that the concentration is achieved steady state and that all these other things are constant. And if you don't do that, you may draw erroneous conclusions.
Well, you have to compare it to the outdoors as well, I guess, because that can change.
Yeah, for sure. Yeah, it's really a relative thing compared to the outside, and and that might not be the biggest source of the error, but as long as you're measuring it inside, measure it outside, so you got some basis, because outside is not a constant, especially in urban areas and certain times of the day and times of the year.
And I think a lot of what this did was pointed out mistakes that you should try to avoid, I guess, when dealing with CO2 or using CO2 to help characterize building environments. Yeah,
I mean, if you're going to make a measurement, you need to understand how to do it, right? You can't, and in my, my career, every time I wanted to measure something new, I never measured CO before, and it's like, no problem. You buy the CO monitor, you plug it in, and you're rolling. And I mean, every time I've had to measure something, it's like, oh brother, I got to learn a whole new thing. There's all these issues. This monitor has its quirks, or this contaminant, has, is affected by temperature or something, and it's always more complicated than you want it to be. Nothing, I mean, even temperature, temperature can be impacted by, if you have a cold surface or a hot surface, and your thermometer may have radiated interchange, or if, the air is moving or the air is not moving, or the sun's shining, it's, it's never easy, you got to understand and talk to someone who knows, and they're going to, it could be discouraging at first, but you're better off if you understand the measurement technology and how to apply it. You're much more likely to get some useful information.
Now, another topic in the paper was the control of outdoor air ventilation based on CO2 concentrations, which is, I think, a real common thing that's occurring in buildings today. What are some of the issues that people should be concerned with when using CO2 to help with controlling ventilation rates?
Yeah, I mean, I'm not I don't design HVAC systems or develop, the controls, but, people have been using, CO2, a lot of ventilation systems, especially in commercial buildings, they have to have part of the design is how much outdoor air do you need to bring in. And that's usually based on the design occupancy, right? And so there are some spaces where you're not necessarily going to be at the design occupancy all that often, or all that regularly. Conference rooms, movie theaters, auditoriums, and so on. And so from an energy efficiency perspective, why ventilate at the design occupancy where you might be at a quarter of the design occupancy, 10%, or no occupants. So it's an energy efficiency opportunity to ventilate, for the actual occupancy, and CO2 demand control is a way to do that. And it's been around for decades, and it's actually required by some energy efficiency standards. ASHRAE Standard 90.1 requires demand control ventilation for certain spaces, high occupancy spaces. I can't remember exactly how it's written. And so it's an energy efficiency strategy. It's also, it can ensure that you provide enough outdoor air. So if your occupancy is high, that you're getting enough air to meet the ventilation requirements based on the actual occupancy. So it's good for indoor air quality too. There's issues of how many controls, how many sensors do you put in, where do you put them, how often do you calibrate them, the control algorithms, the math that the control system uses to take that reading and control the damper. And how do you lay that out? And that's not, you want to talk to a real design engineer. But I will not mention it by name, but there was a famous green building that had CO2 demand control, and it had the sensors and it had signals, but it had no mechanism for adjusting the outdoor air damper. So they had all this feedback going on, except there was one key part of the feedback loop that didn't exist. So it had, they said they had demand control ventilation, they just didn't have a mechanism to modulate the amount of outdoor air. So they weren't, benefiting, from the energy.
Interesting.
Yeah.
Very interesting. We've got to break and thank our sponsors here. When I come back with Dr. Persily, we're going to go into the impacts of CO2 on building occupants, and then airborne infectious disease transmission, which I think are some topics that you get kind of mixed bag on what people are talking about. So looking forward to that. Also, I'll get to these text questions. So we'll be right back with Dr. Andy Persily. Our marquee sponsor is First On Site, your trusted full-service disaster recovery and property restoration company at firstonsite.com. Association sponsors are AIHA, Healthy Workplaces, A Healthier World, AIHA.org, ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science, ACGIH.org, The Cleaning Industry Research Institute, see more deeply through science and research, CIRI Science.org. The Indoor Air Quality Association, IAQA.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. Industry sponsors are AEML Laboratories, free shipping, great pricing, same-day results with no rush fee, AEMLINC.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations, TSI.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs at sunbeltrentals.com. April Air, healthy home, April, AIRE.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, we're back with Dr. Andy Persily. Andy, I've got two text questions I want to try and combine here from Kishore Kankari. Dr. Kankari, great to see you online here. He's asking about buildings are for people, so that our buildings should be more human-centric. And then he talks about the breathing zone of occupants is the most critical zone. After we talked the other day, I was thinking about it. I'm like, we almost have the technology now where your wristwatch should be able to tell you what your CO2 levels are for the individual. I'm wondering if if you're seeing any trends toward, measuring right at the individual as opposed to having a remote sensor, and if you thought that would help at all.
Sure. I mean, people have been doing that for a long time. It wasn't not that long ago. I saw some journal paper where they were kind of measuring the CO2 concentration, like right here, but they were kind of timing it to the breath because they didn't want to, have interference from the exhalation. So they were, kind of measuring when the person inhaled. So they picked up, the exact concentration that they, that the occupant was faced with. And, absolutely, bigger picture, buildings are for people. Buildings aren't for architects to brag about the marble in the lobby. Buildings aren't to brag about your low utility bills. Buildings are there to support the activities of the occupant, whether it's work, school, healthcare, or hanging out, and ultimately, in terms of air quality, it's the air that the person breathes, which the last stop on the train is right here, and the first stop, I guess, is the outdoor air intake. Sometimes I feel like, let's get it in the building. That's step one, and that's challenging enough in some cases, and then ultimately, yes, you got to think about the last stop on the train, where the person is doing their inhaling. We've been hearing about personal ventilation for decades, where there's, a local vent, it's not like over there in the corner and you're thinking about how to deal with, thermal plumes and all that to get it to the person, but it's built right in to the workstation or something. And that's an option, probably more of an option in some buildings than others. If you're stuck behind a desk, it's done there. And I people have done that in classrooms, I guess, in lecture halls, where they put it into the chair in front of them. They're delivering the air right there, and that has a lot of benefits in terms of the effectiveness of the ventilation, and it might even, often could allow you to bring less outdoor air into the building, reduce your heating and cooling load. So, it has certain advantages, though I will say, whenever I hear about a new technology in a building, I quickly start to think, who's going to take care of it? We can, in a lot of buildings, the filters aren't getting changed. No one's ever looking at the dampers or the sensors. And so there's a big maintenance issue already. And if we're going to put more stuff for those poorly funded maintenance programs to deal with, I kind of will have to wonder about that.
I'll get to a couple more of these texts in a moment here. I want to get over this next section, which is the impacts of CO2 on building occupants. This is the one that's kind of been, mixed results. I'm wondering, what's your gut tell you on that one, Andy? I mean, I know you're a scientist and you want to get to the, what's your gut tell you? Is CO2 a problem, or is it just telling us there's something else that there may be a problem?
Well, I just read a book where it said you shouldn't trust your gut. So, you should use careful exercises to arise at some judgment call. But, I think, less than my gut, but, the research literature and the medical people, I think historically we've all said, don't worry about CO2 till you get up to 5,000 or 10,000, based on OSHA limits and so on. And people kind of poo-pooed concerns at lower levels. And, if you look at there are more sick building syndrome symptoms above 1,000 ppm than below, but everybody felt it wasn't the CO2, it was the fact that you had low ventilation, so the CO2 went up and everything else went up, and that the everything else was causing those sick building syndrome symptoms. And it makes sense, but that's really hard to measure, but a lot of those health studies, historical health studies, are focused on occupational settings or workplaces in general. They're based on, healthy white males, and not the general population of folks with pre-existing health conditions and the young and the old. So some of the recent work as I mentioned earlier, that showed, some impact on cognitive performance of CO2 concentrations at kind of, what do we call them? Typically observed concentrations, 1,000 ppm. That was pretty interesting and maybe even a little surprising. And, my gut may have been suspicious, but what does my gut know? My gut doesn't do research. And so other people did similar studies, with slightly different designs, and they didn't see that effect. So it's kind of like, what's going on? Some people have done, I guess, in the medical side, you measure an effect, on something, but you want to understand the mechanism, what's happening physiologically. So some people have looked at mice, I guess, and seen some things, that could, lead to some physiological explanations for some of those effects. But it's early, there's not a lot of data there. I think if 1,000 people was making people sick, we'd see that, because it's so common. If it's slowing them down a little bit cognitively, that could be in the noise. I don't know. There's so many things that can, reduce your cognitive performance or your work performance. There's so many things. And, I know a lot of us have, people have experienced that over the last year, being stuck in the basement or,
right.
Just stress, and I can't compare, the relative impacts of those, but they appear to, maybe they're subtle effects, but I think more research is needed there. And the ASHRAE position document, that's not, I'm just really repeating what's in there. It's really not me, and I'm not a health person. I'm an engineer, and I read some of that stuff, that health stuff, and some of it I even understand. But
well, it's just sometimes a little scary when you think people were in submarines with nuclear weapons operating at 5,000 ppm. Is it actually affecting their cognition in some way? And and if it was, why haven't we seen more problems? Or maybe there have been, and we haven't heard about it.
Yeah, and I haven't been in one of those submarines. I'm going to guess they're probably not the most delightful environments, right? But they got a job to do, and they don't send just anybody down there for months at a time. I'm sure I would assume there's some kind of screening, and I'm sure I would repeat that screening. And if they screw up, as long as they don't push the button. If they screw up in some other way, they maybe they get weeded out. I don't know that. I don't know that process.
Cliff, you had a follow-up?
I do, Andy. What's the relationship between oxygen and CO2? The reason I ask is that there's certain people that need oxygen, so they have these little oxygen generators, and they can carry them around, or they can put them in a room, and so on and so forth. So when CO2 is high, does that necessarily mean that the amount of available oxygen is lower than normal?
I don't think necessarily. We're going to stay away from like confined spaces, where people are working in some underground chamber, where with very limited ventilation, right? Because that's a whole specialty that some of our industrial hygienist friends would know about. Oxygen sea level like 21%, and if you go up to Denver, it goes down, but it doesn't go down that far. And so the swings, the relative swings in oxygen, I think, are smaller than the relative swings in CO2. So while it's 400 CO2 outside, and it might be 1,000 in the office, and it may be several thousand in a poorly ventilated auditorium or something, relatively speaking, those are bigger swings, and the oxygen is probably not going down that low. I've seen calculations where, how much air do you need to kind of maintain oxygen levels in the range? And it's like maybe it's a CFM per person or something, or even less. You don't need a lot to replace the oxygen. You need more to keep the CO2 down, especially if you think what down means, where down should be. So, and you know, people consume oxygen and release CO2, and there's you know, the ratio between those two rates is, to a large degree, is a function of their diet. You know, how many fats, carbohydrates, and proteins. And I am not a physiologist, or I've read a little bit about it, though I do find it interesting that they say that alcohol is important too, but they leave that out of the calculation.
Let's go to airborne infectious disease transmission and CO2, and people were using CO2 to kind of help with determining whether there is a significant airborne infectious disease transmission potential. And I think you want people to be cautious about that.
Well, you know, especially now, I want everyone to be cautious all the time, especially if they're getting near me, right? You know, I'm really going to basically say what's in the position document. There's really two approaches to using CO2 in the context of airborne infectious disease transmission. You know, the first is really as a tracer gas. If you know how much ventilation you think, or you think you know how much ventilation you need to manage the risk of infection, of airborne infection, you know, and you can use CO2 as a tracer gas to kind of verify you're getting that much ventilation. And some people think you need more, you know, than is commonly recommended. Fine, you know, whatever the number is, you know, if you have occupants in the space, you can use CO2 as an indicator of that ventilation rate. So that's kind of the tracer gas approach to verifying a safe ventilation rate. You know, the other is using CO2 as a more direct or indirect indicator of infection risk itself. And there's a concept that was developed several years ago called rebreathed air fraction. And the idea there is that the CO2 level in the space is a reflection of how much air in that space somebody else exhaled. You know, and if some of those somebody else's are infectious or contagious, you know, then the CO2 will capture, you know, kind of the contagion level in the space. And there's people have been looking at that, and it's described in the position document. It's really important to bear in mind that an infectious aerosol behaves very differently than CO2. You know, aerosols will deposit on surfaces. They'll get removed by filters and portable air cleaners, and the CO2 won't. So it's not a one-for-one match, and that these pathogens are very different. You know, some are super infectious, like measles, you know, and others are less so. So, you know, and CO2 doesn't know that if CO2 is representing a pathogen, well, it's not. You know, it's not going to represent, you know, a specific pathogen because they're all so different. So it's important. Again, it's, you know, it's a tool, and you need to understand how you're using it and what it might tell you and what it won't tell you. And the position document has much more detail. And the most important thing you didn't say about the position document is it's free, right? You can go to the ASHRAE website and download it and read it. And it's got all the upfront material, and then it's got a really nice, detailed, heavily referenced appendix, which really digs into things.
Excellent. All right, let me get one more question, then we're going to go to the roundup. Actually, it's not a question. I want to look at this online tool you helped to create, and I'll ask if you could kind of walk us through what it is for folks.
Yeah, and the motivation here is, I mentioned earlier that all these people said, you know, and still are saying, you know, 1,000 ppm, you know, that's the cutoff. You know, below 1,000 ppm, everything's great. Above 1,000 ppm, head for the hills, right? And you know, 1,000 ppm is a reasonable indoor concentration if you have corresponding to a ventilation requirement of like 15 CFM of outdoor air per person. You know, and so if you have a space where you want to provide 15 CFM of outdoor air per person, then you know, 1,000 might be a good target. But you have to assume a ventilation rate and how much CO2 the people are generating. And so, you know, if you look at other spaces that are more densely occupied, like a conference room or a lecture hall, 1,000 isn't the right number. if you look at the standard, and for now, we'll assume we're using the standard 62.1 ventilation rates, and you make some assumptions about the people in the space and how much CO2 they're generating, you're going to get different concentrations, in some cases well above 1,000. And I'm not going to say the 62.1 numbers are right for all time, but I'm going to say the 62.1 numbers are the 62.1 numbers. So what this tool allows you to do is to calculate the expected CO2 concentration that you would see in a space for a given ventilation rate and for the given occupants. If you go back to that input window where you were, there you go. And it has some predefined spaces. You can see some here where we put in the ventilation requirements from standard 62.1. We made some assumptions about the people, their sex, their mass, their age, and how active they are. And that tells you how much CO2 they generate. And then, you hit results, and it calculates the CO2 concentration at steady state, an hour after occupancy. It tells you how long it gets to steady state. And you can do this for two different ventilation rates. You could use a 62.1 rate, and then you could enter an alternative rate just for comparison. So this allows you to estimate CO2 concentrations that correspond to your specific circumstances. And they're not all going to be 1,000 ppm. And so, the part of me was like, screaming and yelling, don't use 1,000, don't use 1,000. And that's not very constructive, so I got that out of my system. So it's like, what should you use? Well, here's something to use. And so earlier we saw the subset of the buildings covered by 62.1. We also have some residential occupancies as well. And while there's some predefined cases, just like miles per gallon, the mileage you realize will depend on your particular circumstances. So this is out there for people to use, and
John will put the link in the there it is. John put the link up right there. So
yeah, and there's a report that describes it in a little more detail, kind of has a user's guide and kind of explains the concept behind it. It's not, we should have a link on the website. I'm going to talk.
We can put that in Cliff's blog too.
Yeah, but I'm going to put that.
Send me that report.
Put that on the website if it isn't already there.
All right. Well, John, let's go to the roundup, buddy. The roundup is brought to you by AHRAE, providing healthy humidity, ventilation, and air purity solutions for new and existing homes. AHRAE, healthy air, healthy home at AIRE.com. All right. So for those of you that have text questions in here, I will work with Dr. Persily here, and we'll put them up on the afterthoughts.iaqradio.com site later. And Cliff will have some of this information in his blog as well. Cliff, any questions you might want to jump in here? I've got a couple.
Thanks, John. Joe, I was just going to paraphrase one, Andy. One of the questions I thought brought up a very practical point. Typically a building may only have one air handling system, and that supplies the air, both return and supply, to all the rooms. So how practical is it? You can't really vary it, right? So I guess how practical is really the monitoring when you can't really change it on a room by room basis?
Right. Well, you ask how practical it is, one air handler per building. Well, it's pretty darn practical, because that's what you're faced with. That's reality, right? You may want this and you may want that, but you're not going to put in a whole new air, duct system and air handling system next Monday, right? So you kind of gotta. And there were a lot of recommendations during the pandemic to up your ventilation and do this and do that. Well, that's great, but you got to start with what you have. And depending on your options are defined by where you are. So practically speaking, so you have one air handler, it limits what you can do, right? It's I guess it has the advantage if it's one air handler, in terms of maintenance and checking the dampers and changing the filters. It's a lot easier than having 2 per floor in a 50-story building. So, but it just, limits your options and the duct system's in place. And, if you want to monitor, let's just pick on CO2, because this is the topic of the day, you could measure it in the return going back to the air handler, but how does it vary in the building, And so maybe it gives you a fair estimate of the average, but you don't want a fair estimate of the average. You want it in your office and his office and her office, and putting in a lot of sensors. They're not as expensive as they used to be, and some of them are wireless, but then immediately that triggers my thinking is who's going to take care of all those sensors and who's going to calibrate them. And some of them say, oh, we don't need to be calibrated, and then that's a pretty wonderful scenario. But I think if you want to know what's happening in that room, and if you want to know what's happening in the air that person is breathing, there's no option. You gotta look there. You can't be up in the mechanical room looking at the return airstream. You're probably going to miss some important factors.
Thank you.
Let me again, we'll get to some of these questions. I'll email back and forth with Andy, but let me go on to with all the work you've been part of over the years, let's talk about some of the most important documents that would help someone managing or evaluating built spaces. Can you kind of go down the list, and then we'll put links up for those documents in Cliff's blog and on the afterthoughts?
One that that comes to mind, kind of going back where we started, is the analysis of the ventilation data from the Base Study. I think that's still relevant. It showed that big surprise, buildings aren't always operated as intended. You looked at the measured ventilation rates and the design ventilation rates, and they weren't necessarily all over the place, but there was a lot of cases where the actual airflow in that system did not match the design intent. So I would say that the base ventilation data, even though it's, 25, that report is 20 plus years old, that's still relevant. More recently, I wrote a review of field measurements of ventilation rates in buildings. And I think that might have been 2015 or something in that time frame. And most recently, there's this handbook of indoor air quality that was published 20 years ago, and John Spangler, and I forget, yeah, you got it.
You got it up here.
Yeah, somebody told me, that it was on eBay for like $700 or something.
Yeah, it's not cheap.
Yeah. So there's been an effort, that's being redone. And I wrote a chapter on ventilation evaluation in the new handbook, and that's up there. It's also on our website since I'm a federal employee. What I write can't be copyrighted by anyone else, has to be publicly available. So this chapter on ventilation assessment in the new IEQ handbook, I think could be useful to people. It is not a cookbook. It's more of a menu, right? The cookbook would have to be like hundreds of pages long, and this was like a 20-page limit. But it kind of lays out why you do it, why you would evaluate ventilation, what are the performance issues, what are the parameters, and what are some of the measurement methods.
And when do you think that will be coming out?
My chapter's out now. That's
okay.
on the, if I didn't send you the link, I can.
I think we do have the link. If I don't have it, I'll let you know. We'll
yeah,
put it
that's
up on the blog.
Now, since everything I do is paid for by the taxpayers, everything I do has to be, made publicly available. So that's on the NIST website. If you can't.
What about the revised book? Is that out yet?
I think what they're doing is, I'm not sure it is. I know they're kind of doing a chapter at a time, and they've got to be making money, right? So they must be selling some of this stuff. So I'm not sure exactly how they're doing it. They were posting chapters as they were wrapped up, but I do not know the later. I think it's Springer Publishing is,
Okay.
Is
So
doing,
it's right around the corner anyway.
and some of the stuff is definitely done already.
The other thing I wanted to ask before we go, I always ask this of people like yourself, that have been involved for many years in this industry. What do you see as kind of like up and coming issues with respect to indoor air quality?
Yeah, let me close. Yeah, so I just posted that link, and this is not an endorsement by NIST or the federal government of Springer Publishing or anything, blah, blah, blah.
Well done.
Some of the trends, sensors are getting cheaper and more numerous and more powerful and in some sense more exciting, right? So, low cost sensors, and though, if you're going to measure all this stuff, what are you going to do with all that data? It's very easy to, there's all these people who bought these cool devices and they put them on their coffee table and they have friends over for a beer and they point at it. But what do you do with that? And the light goes red or light goes green. I don't know what to do with it. But, low cost, Internet of Things and all that stuff. Obviously, the pandemic is huge, and it's brought indoor air quality and ventilation, center stage again. We've always known it's important. We've always known that it's important to keep your ventilation system in tune and to deal with indoor air quality issues. That's not a surprise for anyone here, is it more important now? Perhaps it is, but at least there's more awareness. I think, was it last week? I can't keep track of time anymore, but there was a White House event stressing the importance of indoor air quality, which has never happened before. And we're sometimes the way we do things in this world is kind of motivated by the crisis of the day, and so you got to seize the opportunity because, we always have a long view. So,
and another crisis may be right around the corner. So
yeah.
The attention changes quickly. But you brought up a good point with that. That was a very good event they had. We'll put the link up to that. The White House had Joe Allen was on there,
and I think there are. I'll kind of lump them all together. Climate change and resilience. Are other, I guess, important trends. If it's getting warmer outside or there's more big storms and there's more flooding, kind of dealing with those, whether, they're kind of acute, intense disasters or longer term changes. And, that's a whole list of issues really, but that's all pretty important stuff, and it doesn't, not everyone suffers those consequences equally.
Real quick, I'm running a little over, but what's NIST? What's currently on the docket at NIST? What are you in your division there? Your former division, I guess it would be. What are they working on?
Yeah, I mean, a big, I'm sure I'm going to forget something, but a big area is integrating buildings with a smart grid, right? So the modern electric utility structure, it's got to change, and there's more renewables and more storage, and then, how do you integrate buildings with that? And a lot of it is really data exchange and interoperability. That's a big area. Another thing that the division is working on is low global warming potential refrigerants. The current refrigerants are being phased out based on climate concerns. And that's not a political thing. The industry is doing that, internationally. And some of those newer refrigerants are mildly flammable, and so NIST is working on how do you measure that flammability, which is really hard, and how do you predict it? And because a lot of what industry is going to do is going to be mixtures of refrigerants, to optimize the energy performance and flammability, and how do you predict the performance of a refrigerant mixture? there's a lot of people working on that. I'm kind of not really talking that much about indoor air quality. I'm talking about some of the other issues.
Well, we also deal a lot with building science, and those issues are right up there, with some of the current concerns with people.
Sure.
And it's just fascinating. I don't think people think about what, like, measurement the way people at NIST do. How do you measure time? How do you measure the size of things? And is it accurate? And is it reproducible? And I think it's fascinating to talk about those things.
It's not, and it's not just interesting. I mean, the GPS technology wouldn't exist if you couldn't measure time accurately. And you would never get these small, microelectronics and nanoelectronics if you couldn't measure distance accurately. So it's really, it affects everyone's everyday life. In your next broadcast, you should have a trivia question. People can't use the web, but what are the 7, SI units, the fundamental SI units? Because that's international, and they, in the old days, they were based on objects, on artifacts, and they just, within the last couple of years, they retired the last artifact. The kilogram that was in Paris, they don't use that anymore, and there's no more, they didn't throw it in the trash, but they don't base, mass measurements on that kilogram anymore. And they don't base it on that meter stick. They're using, the wavelengths of lights and fundamental constants of physics, so that, it's much more transferable and more accurate. So I'm kind of drifting off the SI stuff, but the 7 SI units, everybody should know those, and they're hard to remember.
All right. Well, we'll put that in the blog, Cliff, if you can. And Cliff, any final thoughts or questions?
Yeah, I will. I will. In trying to put together a trivia question today, I had no idea that NIST, the roots of that go back to the founding of the country and having accurate coinage and measurement of the coins and purity of the metal and so on and so forth. I mean, it goes like way back to like the 1700s, So.
Well, then you guys talked about.
Yeah,
go ahead, Ed.
There was a story, I don't even know if it's true, and I'm sure it's partially true, that there was a big fire in Baltimore, and all these fire departments from different places in the region, they came there and they pull out their hoses and they wouldn't connect. Because everybody was using a different pipe fitting. And that was like, there's a standardization issue.
Your last discussion made me think back to grains per pound. What is a grain? And at one time was based on, I believe, a grain of rye or something like that. But it's just fascinating what, things that get passed on year after year after year, and people don't realize where it came from. And then NIST's job is, I guess, to make it science.
Yeah. And there's a pretty cool museum there, kind of, some of these objects that, people used way back when to measure this for the first time or that for the first time. It's interesting stuff. And again, as I said earlier, the older you get, the more you like history, right?
I hear you. Well, thank you, Andy. Dr. Andy Persily, we appreciate you joining us this week on IAQ Radio. Very interesting show, kind of drifted in a different way than I expected, but that's great. We appreciate it, and hopefully we'll get you back before it's 12 more years.
Yeah, I'm going to be harder to find in 12 years. So, but good to see everybody, and hope it was interesting.
All right. Well, this is Radio Joe Hughes saying thanks to this week's guest, Dr. Andy Persily, of course, to my co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith at the controls. Our growing group of loyal listeners. Also, next week, we're going to do a flashback show to Dr. Persily's first show with us. We're going to do that for the Good Friday weekend. And then in 2 weeks, we've got Elliot Gall from the University of Portland. And we're going to talk to him and Dr. Gall about a couple interesting new papers he's had out, and look forward to talking to everybody then. Please come back in next week for our flashback, and 2 weeks for the next live show of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.